So I wanted to mention to Celeste while I was reading this book, Earth. It's an introduction to physical geology. With geology, there really isn't a lot of chemistry-related stuff, which is very, very strange. I looked at this whole thing. The majority of the chemistry stuff they mention basically has to do with chemistry as it is now. If there's acid rain, if there are hydrothermal vents, if there are processes that erode certain types of rocks quicker than others. But for the most part, chemistry isn't mentioned. And that's very, very strange when you look at it from a very unbiased viewpoint. That viewpoint is, well, all of Earth is made of entirely of chemicals. So the formation of Earth involves all chemistry. The formation of Earth requires chemistry to understand how it forms. And just to verify that I'm not actually stealing this idea, I've looked over this book, I've studied lots of geological papers, I've studied a hell of a lot of stuff when it comes to the Earth and how it formed. And I like to believe that I have a firm grasp on what's going on here. But before we continue, Sophia, my oldest, did that. I like it. I like how scared the bacon is. Doesn't look too thrilled to be abducted by the egg. But I really like this one, Sophia. Good job. The iron nickel cores of ancient stars is where we need to start. Because in order to form something the size of the Earth and its huge, massive amounts of chemicals, is you first have to form a core. You have to have some type of foundational structure in the center to layer everything on top of. Otherwise, it'll just collapse on itself. Think about building a building or a skyscraper. You dig out a big hole and you pour concrete and steel foundation, and then you work your way up. Same thing with the Earth. To make something this big, you have to start from the very bottom and go up. And that's exactly what a star does as it cools and collapses. I took this from another paper. It forms its core first as it cools and collapses on itself. That being said, regarding chemistry, the word of the day is catalyst. A catalyst is a element or a molecule or a biological compound of sorts that speeds up or slows down a reaction. Or it causes reactions to take place altogether, and without the catalyst, no reactions do take place. And when it comes to the Earth, being that the Earth is made entirely of chemicals, and being that it also has iron and nickel in its center, as well as other catalysts. Here's a piece of meteorite, this iron nickel alloy. It's entirely made of stuff like this, and osmium and iridium and other types of elements that are good catalysts. That tells me that those catalysts were non-consumed. In other words, they were not combined with other elements as they caused the other reactions to take place. And they entered into the Earth's atmosphere over many, many hundreds of millions of years and caused a lot of the chemistry to take place inside the atmosphere of the star as that iron slammed into the atmosphere and sunk down into the center and was further chemically mixed and physically mixed altogether. But eventually, the non-consumed part, the part that does not make pretty minerals like pyrite, which is iron sulfide, so one iron and two sulfur atoms combined. The stuff that doesn't make a compound or any type of mineral sinks all the way to the bottom of the star and collects in the interior in huge quantities. And the reason why they're huge quantities is because, well, it's been around, it's been wandering the galaxy or other galaxies, mind you, for extreme periods of time. And as it was a gas giant, as it was a very young star, it had lots more surface area, so it could collect more material, and its gravitational field was stronger. So over many hundreds of millions of years, the Earth collected up its iron nickel core, which then had non-consumable, well, not non-consumable, but mostly non-consumed iron and nickel in it, and which then sunk to the center. And eventually what ended up happening is it started cooling off, and more iron and nickel started entering in, so that iron and nickel then started becoming consumed more and more and more as you work your way outwards. And we see some of the iron and that was consumed in iron banded rocks. We see that iron in iron ores, such as magnetite and hematite. And basically that really sums it up. But to say that no chemistry was involved during the formation of the Earth, when you have purified iron and nickel alloy in the center to the tune of hundreds of millions of cubic kilometers of material, this is just a little nothing compared to what's in the interior of the Earth. There's a whole hell of a lot of this stuff in its purified state. How did you get all this stuff to be so pure? Why is it that a lot of this stuff doesn't have any oxygen or fluorine or nitrogen? Why is it so pure? It's because it functioned as a catalyst, and that catalyst was non-consumed and it collected all together in the center. But I've tried to find that in this geology textbook, but they don't ever mention it. They don't talk about it. It's because they don't know. And inside of Mercury, inside of Mars, inside of Venus, that's why they also have huge iron nickel alloy cores, which, would trace other type of catalytic materials such as iridium, osmium, that type of thing. As that star cools and collapses, that unconsumed iron and nickel collects in the center, and eventually those core remains are further smashed up into bits and pieces, and they become just solid iron nickel balls that just float around the galaxy until they enter into a hotter, younger star and get recycled again. But that basically sums up this talk. Just to look at the Earth as being the vast remains of a huge chemistry experiment, where a lot of the material that had settled inside the star took up crystalline form, took up different chemical compound form, and became extremely complex when the star was in very late stages of evolution. And those more and more complex compounds and molecules were spurred onto the complexity with carbon, and that carbon, is obviously the base for a lot of organic compounds. That's the basis for organic chemistry. A lot of that carbon stayed on the surface because it was material that didn't necessarily sink into the center along with the iron and nickel. All right, you guys. I think that sums up this talk. Again, I like the abduction scene. All right, y'all. Later.